an educational series on cybersecurity, compliance, and IT governance. Produced with the support of Freedom Technologies, Phoenix's leading managed service provider.
All right, without further ado, here's Rich Larkins to talk about data centers and why we should all be very scared about where our data is.
That's by default. Let me see here. All right, we'll go ahead and share this. How's that look?
I think we're good.
All right. I'll move the chat window over here in case somebody wants to abuse me. All right. So what I've got here is a presentation that I created about a year ago for the ISSA, and I've kind of done a few updates to it since. It's not a professional presentation, so don't hold me accountable for any of the graphics. But this is in, basically the guy from The Princess Bride just puts it all together. The inconceivable word applies to a lot of this stuff. And what this is, okay, now come on, there you go. So these nightmares that I'm going to describe are real. They did happen. Names and places of these incidents may be changed or omitted to avoid issues unless information is already made public. And by the way, I'm not going to go into my background and my profile, my LinkedIn, whatever. If you want to find me, you know where I'm at. I'm on LinkedIn. Most of you know who I am. As mentioned in my bio, I've got enough expired Cisco certifications to fill a file drawer and other things. I entertain a CISSP just because I have to, and things like that. But basically, I'm a principal staff network systems engineer. I deal with networks in large scale. So the key here for everything that we look at is availability, right? That's what everybody wants. Everybody wants their access to the systems and the data they need, right? So you go into the CISSP, there's the old triangle up there for CIA. And it comes down to risk, the quantitative versus qualitative. What does it actually cost you to do this? What's the analysis? What's the total value of the asset? There's a bunch of math involved. But what I want to kind of go into is the qualitative. How likely is it to happen, and how bad is it if it does happen? Actually, I can say how likely is it to happen. I can guarantee you that in your career, you will run into a situation where the availability goes to shit. Excuse my language. Anyway, it's after 8 o'clock, right? Okay, we can do that. So, of course, we all talk about the cloud, right? And in my parlance, it's just somebody else's computer, right? Well, yeah, and it's also someone else's data center. This actually happens to be the Switch data center. It's a tier 5. Unfortunately, they wouldn't let me. I had to go find this picture. They wouldn't let me in the Las Vegas NAP when I was up there. They wouldn't even let us into the NOC for that, which was unfortunate because it was really cool. And yes, they do all the fancy graphics and all the cabling's perfect. Everything's beautiful. This is probably the hot aisle, it looks like, because they end up doing enclosures on the cold aisle. If you don't know the difference between a hot aisle and a cold aisle, you might want to go look that up if you're ever going to rack up some computers, even if you're going to do it in your garage. Work out your airflow stuff. But the whole process about putting systems in a data center is about availability. And people like to talk about 4 nines, 5 nines, 6 nines even. That's the tier 5. In terms of availability to the application, that turns into an outage for like tier 5 is 6 seconds over 1 year. And you'll see these numbers pop up in things like SLAs for your applications and systems. And what is that? Eric, was that you? The picture from day one?
Yeah, that was me. All data centers look like that day one.
Day one, yeah, I know. 1 year, 2 years, 5 years, it turns into I've got some pictures that'll scare the hell out of you, from various labs that I've been in. But again, it's all about how much, and what it is. It's higher uptime equals higher cost. I mean, to make that pretty data center costs a lot of money. And so, you trade money for availability, or at least you think you do, right? So what are these nightmares that I talk about? Things that don't involve Python. First, well, some of it might, especially with the one I just crossed off there. But, power, cooling, networking, as much as I hate to say it, networking does cause some nightmares, and people, right? These are basically the four horsemen of the apocalypse for data centers. And I'll show you why here in a minute. So this slide was updated on 11/25 of this year with Eric's wonderful intro that he gave me. I want to dive a little bit into Amazon, and it's right in the contracts that says application owners are ultimately responsible for availability and recovery. So you can have regions and availability zones inside those regions and things like that. But if you don't have multiple region capability, you're kind of at risk. And one of the reasons for that is this Kinesis data stream. If you look at just this last November, for 12 hours, US East 1 region went completely offline because, well, they were, you can see they started about 6:30 in the morning PST. Their increased error rates for Kinesis, and then they keep working through. Finally, about 12 hours later, they released the system to say they're fully integrated with the impact. And the root cause of this was an attempt was made to add a small amount of capacity. And I do that small amount in quotes because that's exactly what they said. It's a small amount of capacity to the Kinesis service. Now, this Kinesis service is a layer 7 data stream, for lack of a better word, load balancer / firewall / packet analysis / all the above, right? And so it defines all the flows in and out of a region and allows you to tap into those flows at any given spot and time and do analysis, get statistics and all that wonderful stuff. And I've got, if you want, I can pass on the slide. There's a website from, I think AWS had one that had the heavy details, but basically what they did is they tried to add a small amount of capacity, and it then started cascade failing the servers in the cloud, and it exceeded the maximum number of threads in the platforms. And so as those servers cascade failure happened with adding the more threads, then recovering it meant they had to kind of back out section by section by section. And it took 6 hours plus for them to remediate the problem. Once they realized what it was with the threads, they had to bring new servers online with more CPU, more memory, things like that, and it was a mess. And there was, Disney Plus was down on the East Coast. There was a whole host of applications that they list that were unavailable, and that's because they were based in the one region. So if you had something in the East region, you lost access to it for a good 6 to 8 hours, which, I mean, any given SLA for cloud services should have some kind of words on that. So Eric, that was that was the lead in you gave me on Amazon. This was fun. So the lesson learned here: don't believe the hype. Anything that intercepts your data for analysis, for recording, for statistics, for routing, for anything that intercepts your data can block your data. And so don't rely on one region, and do your homework in the design of your application and where you have it. So I can also do this for things like BGP, but that's a whole nother presentation down the road if you want to see that. BGP causes more problems in cloud and internet environments than anything else in the world. So going on, here's another data center nightmare: critters and love, I call it. So this is the power, right? Squirrels are among the top causes of power outages across the US. This was from 2016, and they actually have a blog that has what they call the squirrel tracker, and you can see how many outages are caused by squirrels. And so what I'm going to do is I'm going to jump out of this for a second. I want to show you. Come on. There we go. Then there's also birds and there's also raccoons. One of the power failures that I had back in the 90s was, I think, a squirrel or something that got into the substation. They found, or it may have been a cat, I don't know what, but they found bits of fur on top of the transformers. So here's one of my old favorites, Mylar balloons. And you might want to turn your sound either down or up, depending on how you want to do this, but here. So that's Mylar balloons with power lines. And that is also very common. I like that. That's just so much fun. So the lesson learned here, obviously, is commercial power is not guaranteed, right? If your asset is critical, you better have a UPS and generator system. Or should you? Well, yeah, you should, but there's other problems with that. As most people know, I like to include my dog in any of my presentations. This is Orion. He was pissed off at me because I was away for too long. I was halfway around the world working in a NOC. And I ended up with something called the nightmare number 2, which was the auto transfer switch. So for those that don't know, this is a standard diagram basically for data center infrastructure, right? You've got your utility, you've got your, you got your utility, you got your transfer switch, the standby generators, UPSs, air conditioning units, and then batteries, and then of course your load out here on the right. So the automatic transfer switch is here, and this is the device that controls whether you're on commercial power or you're on the standby generator, right? So what happens if that thing actually I'll tell you the story. I'm halfway around the world, and the East Coast of the United States is having utility problems. And a site that I had on the East Coast in the US, in Conus, had a problem with the transfer switch that day. Right, they'd been working on it all day, and they had manually moved it to generator and everything like that. And they thought they had it nailed, right? So they went home at 5 o'clock. Well, I'm halfway across the world, about 10 time zones away, and their utility goes out, right? Which then the transfer switch failed on them, right? It went back to the same problem they had earlier in the day. I'm like, oh crap. So now the utility's down, the transfer switch is down. You've got no row standby generator, right? That's not coming online. And so what's happening is there's no power to the air conditioning units. You can tell where this is going to go. It's getting hot, right? Because the UPS is still up, your servers are still up, the air conditioning is down, and your batteries are getting drained. So it is, it is just a matter of time before those suckers go bye-bye. And I'm sitting at the console in the NOC and happened to look over, and my screen went blank. Like, what the hell? Ended up, in the post-mortem, we pulled up the alert log, and basically the alert logs were, system is on backup battery, we have half an hour power left. Systems on backup battery, we have 10 minutes of power left. Systems on backup battery, you have 1 minute of power left. Basically the last gasp was, I'm sorry, I'm shutting down, I've got no power, gone. And the whole facility went dark after basically melting itself over 2+ hours, I guess you'd call it. It took quite a while to rebuild the facility, and we learned a lesson. The lesson is never discount the value of your monitoring tools and the people watching them. And by the way, when somebody's watching these things, don't let them just ignore critical alarms. So, yeah, don't let them ignore critical alarms, because they're trying to tell you something that you may not want to hear, right? Any question? Or just somebody open mic?
So I'm just going to add to that briefly. I totally agree. And I would add, if you have non-critical alarms, try to keep them off your board. Otherwise, you train people to ignore alarms.
Yep. So the other thing that happened with this is, okay, I'm 10 hours ahead of the facility. And when you're in a remote knock facility, you have no idea what's going on. So I actually called up the lead person on the call tree. And literally my first question to him was, did you guys get nuked? Are you still alive? Right? So, the first thing you always think about is personnel safety. So we did a head count. We tried to make sure that everybody was accounted for, and that nothing catastrophic had actually happened on the East Coast. But if you're, 10 hours removed, you don't have that visibility. You don't have, maybe today you've got webcams and cams and things like that. But the time I had this, I did not have that. So again, the lesson learned here is definitely, if you got a Q radar display that's telling you something, listen to it, and don't just blow off the critical alarms. And update your call tree frequently. Make sure you've got the current personal contact information of the right people. So going on to nightmare number 3. This one here actually was in Phoenix, and it was not something that I was personally associated with, but it actually was less than a couple miles from my house. If you're familiar with the Talking Stick Resort Casino on Indian Bend Road, just off the 101, it's out in a desert, and you wouldn't think of it as being susceptible to any flooding. But if you look at this topo map, you can see where all of the gradient rolls right into that golf course there, roughly. And so what happened is on August in 2018, this monsoon storm struck. And it was like a cloudburst over the McDowell Mountains in North Scottsdale. And basically all the water ran towards that facility, right? It flooded the golf course to the point where it overflowed, and it actually took out the all the standby generators, the transfer switch, the batteries. They were all in the basement of the facility, and it filled up with 8 feet of water. It totally destroyed the system, right? I mean, literally, it was flooded in the middle of the desert. Nobody would ever think about that. So, the standby generator is gone, transfer switch is gone, UPS is gone. Basically, the IT load crashed. Dead puppies. The only thing is here, this happened the second day of the Arizona State Poker Championship. So there were over 500 people in the poker room with money on the table, and several hundred guests in the casino area and the hotel. They had to be evacuated. Again, personnel safety, right? You have to have your procedures in place to protect personnel. And this was a major event. It's actually one of the premier events of the year out there. The casino and the hotel facility closed down, and obviously reopened for business about 44 days later. Think about that for a minute. You're talking about a casino that takes in millions of dollars a day in revenue, and they were down for 44 days. So the lesson learned here is anything can happen at the worst possible time. But again, people are your first priority. You've got to. But what is your RTO? What is your RPO? Right? You have to tailor that to business needs. How much are you willing to spend to get back online within a reasonable time frame? How long can you last, given you don't have access to your data? So the final countdown. I like that in the chat. But how long can you last? Is this going to take your business out of commission? Are you going to be able to resume operations? And some of this actually plays into the current COVID crisis. How long can you go with having, say, for restaurants, 25% occupancy and takeout only? Or in California, they just locked everybody down until after Christmas, right? Does your business continuity plan contain some of these issues? And do you have a seat at the table when it comes to that? So just when you think you have it figured out, this is one of my favorite pictures. This is the hurricane's Superstorm Sandy back in 2013, and this was actually the World Trade Center construction site for the new World Trade Tower. But the interesting thing here is there's a Pier 1 Hosting had a data center that was on like the 13th floor of the 17-story building, and the generator was on top of the building. But the problem is they had no way to get the fuel to the generator to keep it going long term, right? You know, how do you get your fuel delivery? Think about that. You know, if you've got a facility that runs on generator, how much fuel do you have in reserve? How long can you last? Again, how long can you last on fuel? These guys actually created, you know, got a bunch of users, customers, and operators got together. They formed literally a bucket brigade to bring fuel to the rooftop generator to keep it going during the recovery effort from the storm. So I just find that fascinating. That's actually one of the best stories I've ever heard. So data center nightmare number 4. See, I've got several of these, so we can, you know, I've been in this business about 30 years, and I've seen just about everything, but this one took the cake, right? This is called the human factor, and I'm sorry to embarrass the dog, but the plumber's crack is a prime is a very key thing here. So this is a 400 amp circuit breaker. These are facility size circuit breakers that usually are right in front of your UPS. So, and right behind your transfer switch. And this is your garden variety maintenance guy. Thanks, Josh. This is your garden variety maintenance guy that, you know, is working in the same area as the 400 amp breaker. So what happens when that maintenance guy backs up against that breaker to give somebody, you know, room? There was, you know, not much room in the aisle, so the guy backed up, and his butt was the same height as that green button or red button, and that breaker tripped. And let me tell you what, it makes a hell of a noise. It scares the crap out of anybody nearby and requires special equipment to replace. Well, I say replace because these guys tried, you know, there's where the breaker was right there. And so these guys, you know, obviously the first thing you do is you go get your protective gear, right? Because you're dealing with 400 amp AC power. And they tried to pump it up and reconnect the breaker, right? You have to pump these things up, then push the button. It's the, you know, the Jurassic Park metaphor where, you know, it's okay, pump the breaker up and you see the lights go. Well, it's not quite that dramatic, but it was, it's real similar. You have to pump it up and then push a button. And they tried twice and the breaker would not come back, which obviously is a big problem. But fortunately, they had a spare on a shelf, but they had to go get the PPE. They had to go get these things weigh about 60 pounds. You had to go get the crane and all these stuff. So in the meantime, obviously, because I have no power, I've got no air conditioning, right? My IT load is running on UPS, and I'm sitting here going, tick-tock, guys, what's going on? And, oh, it'll be back soon. It'll be back soon. I said, okay, when do I start shutting down so I can prevent a hard crash of the system? You know, where's our procedures? Where's our, you know, and all this time the lights are out and everybody's running around like chickens with their heads cut off. People are putting fans in doorways, you know, to get heat load, you know, try to offload the heat load and things like that. And so we finally got to the point where I convinced some people that it's like, look, we're going to start shutting stuff down now, and we'll bring it back up when we get real power. They originally told me I had about a half an hour of UPS. Fortunately, we lasted 45 minutes before they actually fixed it and got the power back on. But the lesson learned on this one, you know, people make mistakes. People are the weakest link, period. Done. They don't have windows in my data center, dude. and I think this was in the middle of summer in the desert. So it was actually still cooler inside than outside. But, you know, people make mistakes. Know your loads. Know how much power your system is taking. If you've got 40, 50 racks worth of equipment, have a rough estimate as to what your load is, because that's necessary for air conditioning calculations. That's necessary for your power load input. That's necessary for your UPS calculations. And, most people just start stuffing computers into racks and not worry about it. You've got to know your loads. You've got to know where your airflow is and things like that. Keep a hard copy of your emergency procedures, right? Of your, like a shutdown procedure. If you've got 40, 50 racks of equipment, you obviously have, applications running that need sequential shutdown. Keep a hard copy of that, because nobody's going to be able to remember where the soft copy is. And if you're sitting on the soft copy while you're trying to do it, it gets ugly. Again, script your shutdown procedures as much as possible. This is where your Python scripting comes in. You can create Python scripts that go out and say, okay, are you, kill these processes and then shut down gracefully, that kind of stuff.
So Richard, I'd like to add to your slide right here while you have it up, the one you just had up there.
That one?
Know your loads and script your procedures and so on. I was a manager for a government facility. Basically, it was a government equivalent to a small ISP for a particular project I was working. And I had this continuity plan worked out just as you say here. And yeah, my other colleagues thought I was absolutely nuts when I came in one day and I said, what are the cheapest pieces of equipment that we have?
Mm-hmm.
And they're like, what do you mean? I says, well, I want cheap answered in two terms, in terms of replacing the hardware quickly and in terms of recovering the data quickly. What fits that category? Because I had all those put at the top. And the more expensive they were, the lower they were in my racks. Because then what the other thing I did was I knew what the total BTUs output was of everything that produced heat compared to the total BTUs output of everything that produced cool. And what I did was I scripted this down to, okay, in the event of power outage and we switch over to UPS, if we do not have power restored within 5 minutes, go turn off everything with a blue label, shut it down. If we do not have power within 10 minutes, go turn off everything with an orange label, shut it down, and so on.
You're talking manually go hit the buttons?
No. I'm talking,
okay.
I'm talking shut them down, bring them down in a controlled fashion, shut down whatever databases or servers or whatever it was at that color code level matched for how long were we without power. Because what I was doing was every time we dropped load, we would gain a little bit more time for lack of heat generation. So what I was trying to do was balance how long could we keep the most important stuff up, not lose things, and still bring things down in controlled fashion. And just in case something did melt, because it was at the top, it was going to be the fastest, easiest, cheapest thing to restore and put back. They thought I was nuts until we actually had to run it.
Yeah, actually have to run it.
Yeah,
actually.
It turned out to be quite a data saver and time saver. And so when you put a slide up here that says, yeah, know your loads and, kind of do a tabletop exercise.
Mm-hmm. That's my last slide, but yeah.
Yeah. So there you go.
Yeah. So
well, another point on that, keep hard copy procedures and emergency binders. The other thing is keep them up to date. I can't tell you how many times people have pulled them off the shelf and you look at it and go, well, this would be great if it was 10 years ago.
Right. Yeah. So your emergency binder should be updated every time you do a tabletop.
I agree. And anytime somebody tells me that their process is self-documenting, I always cringe.
Well, I don't want to play catastrophe poker here, but I think I have an all in for you. I actually was on a program where the shutdown procedure was written as walk up to the rack number 1 and pull the breakers. Walk up to rack number 2 and pull the breakers. Walk up to rack number 3, and down the line for 30, 40 racks. And I'm like, are you freaking kidding me? You know, so
that is a way of doing it. Yes.
it is a way of doing it. It's not pretty, and you'll spend a month bringing everything back, and hopefully you've got a database that lives. But, you know, seriously, this is, you know, people don't think about, and that's the whole theme of this presentation. You know, people make mistakes. Stuff fails. It will happen to you. Let me go down. Oops. Come on. You know, it makes me drink sometimes. Yes, that again, this is my favorite meme that I've created. And it comes from actually another presentation that I've got, but that's actually one of my former dogs. And yes, she's drinking out of a martini glass. It is water, and she is at the Cosmopolitan in Las Vegas. But anyway, to sum it up, number one, it's personnel safety, right? You make sure you count all noses and belly buttons. Make sure people are safe. Make sure if the building's on fire, you get the people out first, right? Number two, do your call trees. Make sure you have authority first, right? Let somebody else call the C-level folks while you work. You're not the guy that needs to call the CEO or the CISO or anything like that. Tell the man, get a management team together and say, look, here's the problem. Go inform people. We're going to go to work, right? Hard copy of procedures. Obviously, we talked about that. Keep a flashlight in your bag, please. I've got 2 of them in various spots of my bag. Also, a knife is very handy, a sharp knife. Number 4, you know, empower your staff to act, right? Don't let them sit around saying, what do I do? What do I do? What do I do? Oh, do I really have the authority to do this? Just get them trained to the point where they can say, I will go take care of this, right? And if you can't get the authority, you know, just go do the next right thing. I don't want to sound like a Disney cartoon, but, you know, just go do it. And you don't have a lot of time in a lot of these cases. And you know, time, you know, money is going to just escalate the more it goes bad. Also, review your disaster recovery plan often, even if it is just a tabletop once a year. Update your procedures, update your call list, update anything that's changed in the last year or so. But all of these, I'm telling you, I've run into, except for the talking stick one, every one of those failures you've seen, I have personally seen firsthand. So, and they were not in trivial locations. So, well, I'm done. Any questions, comments, you know, water balloons or other things you want to throw at me? Come on, Eileen. I haven't seen a comment from you all night. So, but anyway.
So I got one, Richard, great job. So how many times do you see organizations that are on the receiving end of, let's say, a healthy vendor risk assessment? They're actually being asked to produce the documentation and being held accountable so that they're managing this risk accordingly? Or do you believe that there's a lot of risk out there that people are assuming their vendors are taking care of things, but in fact, there's a lot of dirty laundry?
There is a ton of dirty laundry because most, well, especially with the programs that I've been associated with, they're mostly in a development capacity. When they're in a development capacity and or, you know, initial system integration and test, most people don't think about these things in the upfront. Yeah, there's some quality folks that like to say that they think about it, but essentially when, for example, the breaker happened, everybody was running around like chickens with their heads cut off. There's, you know, I have been in some where the vendor risk assessment has been part of PCI, and that's actually a lot better, you know, PCI DSS. Fortunately, I got out of that environment, but anyway, it's, you know, there are controls that will force people to do this, but in engineering environments and small, like Steve said, there, you know, or Sam says, there, you know, small ISPs, regional ISPs, things like that. Hopefully there are some people paying attention to these things, but is there something forcing them? In a lot of cases, no. Unless they've gotten burned before, or they have someone on staff that actually recognizes this kind of stuff.
So just staying with that topic, I think what would be useful, and just thinking through future presentations, is a questionnaire or cheat sheet that allows the average data center consumer to hold their data center accountable. How do you uncover that your data center is not, the best actor?
There are some out there. I think I've seen some of them. One of my buddies actually wrote a book many years ago on data center architecture. I'm pretty sure I know there's BTU calculators out there. I know there's things like that. But as far as actual risk, like DRP checklists, I think there's some out there, but I don't know how standardized it is.
But so let's say you're on the outside and you're trying to get your data center, you're trying to uncover deficiencies in your data center that you're a customer for, that they don't want to share. That's always a contentious conversation.
Oh, it is. But you're going to have to put that in your SLA agreement, right? Your only leverage against the provider is your SLA. You can't tell them how to create their data center or manage or otherwise build, test, and otherwise. But your leverage is the SLA for your application, right? If I say,
within the scope of the contract, but on the front end, you're doing your due diligence and your discovery, you're making a decision, do I engage in a contractual relationship with this data center? That's the time to be asking these questions, right?
Sure. And in 99% of the times, they'll walk you around and go, isn't that a great looking generator? Isn't that a great looking bank of batteries or things like that? But all of these scenarios that I outlined this evening had every component you could ever want for redundancy / availability. And it still went to hell in some instances because of either single points of failure or human error.